The aim of our experiment is to determine the mass observation coefficient of copper for gamma particles using GM counter. The apparatus required are GM counter, GM detector, stand, radioisotope gamma source, plastic slides, and copper plates. Coming to the theory part, GM counter or Geiger-Müller counter is a metallic cylinder filled with low pressure gas sealed with a plastic or ceramic window at one end. The ionizing particles passing through the tube ionizes the gas and the electrons produced move towards the anode. The velocity is quite high and they later produce secondary electrons after repeated collisions with the particles of the gas. This process continues in GP and is called avalanche. Quenching is a process used to avoid undesirable avalanches in a GM counter. Mass observation coefficient is given by n is equals to n naught e power minus mu t rho, where n is the transmitted gamma radiation, mu is the mass observation coefficient, t is the thickness, and n naught is the initial emission of beta particles. Since n is equals to n naught e power minus mu t rho, ln n is equals to ln of n naught e power minus mu t rho. Ln n is equals to ln n naught minus mu t rho. Let this be equation 1. Considering n naught is similar to c and comparing to equation 1 to y is equals to mx plus c, for graph between ln n versus rho t, we get slope is equals to minus mu.
Plug in the GM counter and switch on the power supply. Set the time reading to 30 seconds and the operating voltage to 450 volts. Now let's move to the procedure of the experiment. For the experiment, we need to measure the thickness of the copper sheets that we are using. For that, we are using a screw gauge. Now this screw gauge gives a zero coincidence value of 0. Now we are measuring 10 sheets of copper, which is cut from the same sheet of copper. The measurement of these 10 sheets are taken together, and now this gives a value of 47. We divide it with 10, and that gives the thickness of each sheet to be 4.7 millimeters. As a step 2, we will take the background counts. The background count is taken to check on any errors that might affect the experiment. For that, start the counter in the same environment where the experiment is to be performed and for the same time duration, that is 30 seconds. For the first trial, we start the counter. As soon as the light turns off, we get a value of 13. Background counts are taken thrice. We reset the counter and start again. The second trial gives us the value 20. And the third trial gives a value of 15. The mean of these values are taken. Now let's start the experiment. Introducing the source. Plug in the GM counter and switch on the power supply. Set the time reading to 30 seconds and the operating voltage to 450 volts. To take the first reading, the source is inserted using a holder into the fourth slot of the detector. The nearer the source, the better results. We start the counter, setting the time at 30 seconds. Click on the start button and wait till the red light is turned off. Here, the light has went off and we got the reading 522 in 30 seconds. Another trial is taken without making any changes. Click on reset and then start button. When the light goes off, we get the reading 497. As the next step, take a copper sheet, insert it in a holder, and insert it to the second slot, which is between the source and the detector. Start the counter and check the count for 30 seconds. When the light goes off, we get a reading of 387. For the second trial, click reset and then start. After 30 seconds, the light goes off and it gives a value of 429. Again, for the next step, take one more copper sheet, 2 in total, and insert it to the same slot, that is, the second slot of the detector. Take the reading for 30 seconds twice. For the first trial, after 30 seconds, we get a value of 289. Click on reset, then start. After 30 seconds, we get a value of 296. The experiment is continued by introducing more and more number of sheets till 10 sheets are introduced into the detector.
We have already seen the theory behind the experiment and the procedure to be followed. Before starting the experiment, it is necessary to record the conditions like source, operating voltage, preset time, position of the source, and the absorber. The source we took for the experiment was cesium-137, which is a gamma source. The operating voltage and preset time were set to 450 volts and 30 seconds respectively. The position of the source and material was fourth and second slot respectively. The density of copper is given by rho equal to 8.96 gram per centimeter cube. The mean of the background counts which were taken before placing the source is calculated to be 16. Tabulation. The columns required are thickness of copper plates, counts, mean count, corrected count, ln n, and rho t. The values obtained during the experiment are filled in the tabular column as shown. The thickness and the counts that were taken by the Geiger-Müller counter are tabulated in the given table. The remaining columns are filled after some calculations using the following formula. Mean count is equal to count trial 1 plus count trial 2 divided by 2, and corrected count is the difference between mean count and the background count. The table is now complete. Let us plot ln n versus rho t. The graph of ln n versus rho t is found to be a straight line with a negative slope. The slope is given by minus 0.342 cm square per gram. The mass absorption coefficient of copper hence will be mu equal to minus of slope, which is 0.342 cm square per gram. In other words, substituting rho equal to 8.96, mu equal to 0.342, n equal to 100 and t equal to 1 in the equation n equal to n naught e raised to minus mu t rho yields 100 times e to the power minus 0.342 times 1 times 8.96, n equal to 4.67. This means that out of 100 radiation emitted by the source, only 4.67 reaches the counter, i.e., 1 centimeter thick copper slab will absorb 95.33% of the radiation. This is the interpretation of the results obtained for the experiment that we performed. Thank you.